Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think yesterday we were discussing about the reaction of anthracene. And as we know that anthracene is an aromatic compound, it obeys the Huckel's rule, and therefore anthracene is included as an aromatic compound. And the reaction of aromatic compound, as we know that they readily undergoes electrophilic substitution reaction, but that anthracene in some cases it shows addition reaction like Diels-Alder reaction, which is one of the important characteristic addition reaction of that anthracene, and that we have seen anthracene was treated with succinic anhydride in presence of Lewis acid catalyst gives the product the addition take place at 9 and 10 position. The adduct is formed at that, and that's why it is known as 4+2 cycloaddition reaction, which is a famous reaction, Diels-Alder reaction. And then anthracene can be shown the Friedel-Crafts reaction, Friedel-Crafts alkylation as well as Friedel-Crafts acylation, and these are the reaction we were described in our previous lectures. So today what we are going to discuss, half of the part of the chapter we already covered, that is a polynuclear. Now we are moving toward heteronuclear aromatic compounds. Heterocyclic compound, we can call it as a heterocyclic. What do you mean by the heterocyclic compound? That heteronuclear aromatic compound means what? Aromatic compound, as we know that it fulfills the aromatic character and the Huckel rules, those are obeying, and that type of the organic compound are generally known as aromatic compound. Now is a heteronuclear. The name itself indicates hetero means different. This heteronuclear, hetero means different, nuclear means that nucleus. So heterocyclic compound, as we can call it as that classification of, or let us see the definition of the heterocyclic compound. Heterocyclic compound are organic compounds that contain a ring structure containing atom in addition to carbon, such as oxygen, sulfur or nitrogen as the heteroatom. That is the definition of heterocyclic compound. The ring may be aromatic or non-aromatic ring. So let us see first of all, the hetero means different. Hetero means different and nuclear means that nucleus, aromatic compound, that is the meaning of that hetero. And just now we have seen as a heterocyclic compound. Heterocyclic compound. Heterocyclic compounds, just now we have defined heterocyclic compound are the organic compound that contain cyclic ring structure containing heteroatoms such as oxygen, nitrogen or sulfur as the heteroatom, the ring may be aromatic or the non-aromatic compound. So let us see here, heterocyclic compounds are generally heteroatoms. Here remember heteroatoms such as oxygen, sulfur or nitrogen. In addition to that, carbon, heteroatoms such as oxygen, sulfur or nitrogen involved in the ring. So that type of the compounds are known as a heterocyclic compound. Let us see the significance of the heterocyclic compounds. Significance of the heterocyclic compound. Two-thirds of all organic compounds are aromatic heterocycles, and most pharmaceuticals are heterocycles. For example, one of them is, I am showing over here, this is one of the heterocyclic, polyheterocyclic compound I am showing over here, this one. Now on that there will be is a stereochemistry shown over here, and then this is the compound which we can show over here. This is a hetero compound which I have shown here like this. This is one of the compound, and the name of this compound, which is a pharmaceutical compound. This is an example of, for example, quinine. This is an example of quinine, one of the very good, what we can call it as a drugs. 2-3 of all organic compounds are aromatic heterocycles, and most pharmaceuticals are heterocycle, and this is one of the cycle which is shown over. And treatment of this is a quinine, and as we know that 2/3 heterocyclic compound or aromatic compounds are aromatic heterocyclers. 2/3 of all organic compounds, whatever organic compounds known to us, 2/3 of them all are organic aromatic heterocyclic compounds, and most pharmaceutical are heterocycles. Remember, and for example, quinine, which is given here, which is act as a drugs and the medicine. Do you know the difference between drugs and medicine? Drugs is a substance which can taken in a small quantity act as an medicine. If it is taken in a large amount, it can be a poisonous. So remember, this is a drug can be act as a medicine when it is taken in a small amount, then it can be act as a medicine. If it is taken in a large amount, then it will be act as an poison. So that the things you should remember why that drugs are, these are the pharmaceuticals are heterocycles. And treatment of malaria, you know that malaria is the one of the disease caused due to the mosquito bites the human beings, and that treatment of malaria, for 400 years, more soluble and less side effect. Most of the heterocycle associates biological activities such as antifungal, antiviral, anti-cancer, antidepressant, anticonvulsant, antihypertensive, anti-inflammatory, antioxidant, antidepressant, anti-malarial, antifungal, antibacterial, anti-insecticides, anti-uretic, such type of the activities. These heterocyclic compounds are showing, and therefore they are highly important as far as organic or the synthetic organic chemistry is concerned. Many drugs, vitamins, and most of the natural products are heterocyclic in nature. All the DNA bases, DNA means nucleotide, DNA, deoxynucleic acid, deoxynucleic acid, bases present in our body are heterocyclic compounds. Hence, heterocyclic compounds become a very important part of organic as well as bioorganic chemistry, means biochemistry. And the simplest definition which we already made here, the cyclic compound in which one or two more carbon atoms forming the ring are replaced by the hetero atoms like nitrogen, sulfur, oxygen are called as heterocyclic compound. Or another definition of heterocyclic compound you can define in a simplified way, such as heterocyclic compounds are organic compounds that contain a ring structure containing atom in addition to carbon, such as sulfur, oxygen or nitrogen as a hetero atom. And that heterocyclic compound further divided into two types. Let's discuss about that two types of heterocyclic compounds. Just see here, heterocyclic compound further divided into two types, or it is classified into two types. One is called as aromatic heterocyclic compound. Aromatic heterocyclic compound, and another one you can call it as A, and you can call it as second one is a B. B is a non-aromatic heterocyclic compounds. Non-aromatic heterocyclic compound. Non-aromatic heterocyclic compound. This heterocyclic compound, just now we have seen in the cyclic structure, in addition to carbon, the heteroatoms such as oxygen, sulfur or nitrogen are present. That type of the compounds are generally termed as a heterocyclic compound, and that heterocyclic compound further divided into two classes. One we can call it as a aromatic heterocyclic compound, and second one you can call it as a non-aromatic heterocyclic compound. Aromatic heterocyclic compound, that is our object here, to study the heteronuclear aromatic compound. Heteronuclear is nothing but as a, in the chapter at T.Y.B.Sc level we are going to focus only the aromatic heterocyclic compounds, and non-aromatic heterocyclic compound we are not going to study, but just for sake of convenience, or you should remember the additional information regarding as a non-aromatic heterocyclic compounds, and that aromatic compound which obeys or which shows aromatic character and obeys as a Huckel's rule. And as we know that there are the certain criteria for aromaticity, and that what are those criteria, what is that Huckel's rule, that details of that we already studied in our introductory lecture when we start as a polynuclear. Polynuclear means more than two cyclic compounds, means two benzene ring fused together, whatever the compound form after fusion of two rings, where the sharing of two carbon atom, the resulting compound generally termed as polynuclear aromatic compound. And at T.Y.B.Sc there are two compounds which are aromatic polynuclear. One is naphthalene and another one is anthracene. How do we prepare anthracene and the naphthalene in the laboratory? Who synthesize this organic compound in the laboratory first time? You already know that is Howard synthesis of naphthalene as well as anthracene, how they are synthesized and what are their characteristic reactions, means properties of that naphthalene and the anthracene. We have studied in detail in our previous lectures. So here we are discussing the heterocyclic compound, and heterocyclic compound are the organic compound that contain a ring structure containing atoms in addition to carbon, such as oxygen, sulfur or nitrogen as an heteroatom, and that is called as a heterocyclic compound. And that heterocyclic compounds are further classified into two types. One is a aromatic heterocyclic compound and second one is a non-aromatic heterocyclic compound. Now that aromatic heterocyclic compound means they obeys aromatic character as well as Huckel's rule, and that's why they are the aromatic in nature. And that aromatic compounds further classified into two types. One which is called as monocyclic heterocyclic compound. Monocyclic and polycyclic. Monocyclic aromatic heterocyclic compound we can call it, and here polycyclic aromatic heterocyclic compound. Monocyclic aromatic heterocyclic compound ASC and polycyclic aromatic heterocyclic compound ASCU. In short, you can remember this. Generally, here the name itself indicates that monocyclic means single rings present, and that monocyclic which is made up of by the ring, but it includes one heteroatom such as oxygen, sulfur or nitrogen. That monocyclic compound further divided into two types. One are 5-membered ring and another one is a 6-membered ring. 5-membered ring, and here is a 6-membered ring. And 5-membered rings, for example, is furan, pyrol and thiophene. These are the example of 5-membered monocyclic aromatic heterocyclic compound, and 6-membered are the pyridine. Pyridine is the only one which we are going to study here. Some other is there, but we are not going. And here polycyclic means more than 2 rings. For example, here polycyclic compounds are quinoline, isoquinoline, isoquinoline. These are the example of polycyclic aromatic heterocyclic compounds. You might be knowing 5-membered. The structure of furan is this one. Let me draw the structure of that heterocyclic compounds are furan, this one, FURAN, furan. Now pyrol, the structure of 5-membered ring pyrol will be shown here, is a pyrol, PYRROLE. And one more structure, that is thiophene. So instead of oxygen atom, we can draw sulfur. So this is a structure of thiophene. So these are the 5-membered ring which are aromatic. Why they are aromatic, that we will see shortly. But here just remember, these are the 5-membered monocyclic, heterocyclic, aromatic heterocyclic compound. Monocyclic aromatic heterocyclic compound, and they are shown on the blackboard, you can see here. And now is a 6-membered ring. The 6-membered ring, generally the ring similar to benzene, but benzene having all the carbon atom involved in the ring formation, but here in addition to that carbon, one of the nitrogen atom is present, and therefore it is termed as 6-membered heterocyclic aromatic compound, and the name of this compound is a pyridine. So name of this compound is a pyridine, which is shown over here. So that rare. Now here quinoline and isoquinoline, quinoline and isoquinoline, they are belonging to polycyclic aromatic heterocyclic compound. The example of quinoline I am showing over here. Quinoline, you can remember this is a one benzene ring and one pyridine ring fused together. That type of the structure are known as a quinoline. It is belonging to as a polycyclic. Isoquinoline, only the position of that nitrogen atom, just you can change it and the resulting compound obtained will be known as a, this above one is a quinoline and second structure is known as a isoquinoline. Here the nitrogen atom, the nomenclature system, and as we do now, while studying as a nomenclature system, we will learn how to give number to heteroatoms. There are certain rules are there. According to that rule, we will study that nomenclature system. Nomenclature means what? The systematic way of giving the name of the aromatic compound is known as a nomenclature system. The nomenclature system means what? The systematic way of giving the name of the organic compound are termed as a nomenclature system, and there are two systems. One is a common name system, or you can call it as a travel name, and second one is called as a IUPAC or systematic naming system. So according to that, we will see the heterocycles how to give that one. But let us see here non-aromatic heterocyclic compounds. That non-aromatic heterocyclic compound also, they are not obeying the Huckel's rule. That type of the aromatic compound we can call it as a non-aromatic heterocyclic compound. Those are obeying Huckel's rule, fulfilling aromatic character, that compound are generally called as aromatic, and those are not obeying that rule, you can call it as a non-aromatic heterocyclic compounds. There is a Fourier pi electron system is known as a non-aromatic. Those are not obeying that, you remember. Non-aromatic and anti-aromatic, there is a difference. They are the non-aromatic means they are not fulfilling the Huckel's rule. They are not obeying, and that type of the compound are called as a non-aromatic heterocyclic compound. Once again, non-aromatic heterocyclic compound further classified into two types. One is called as a similar to as a aromatic heterocyclic compound. These also classified into monocyclic non-aromatic heterocyclic compound, and another one you can call it as a polycyclic non-aromatic heterocyclic compound. In short, I am written in the blackboard, so you remember that one. Monocyclic, remember here once again, monocyclic further divided into two types. One you can call it as a 5-membered, or even though 4-membered also, but let us see here 5-membered non-aromatic heterocyclic compound, and there 6-membered non-aromatic heterocyclic compound. 6-membered non-aromatic heterocyclic compounds, and here the Here the example are THF. THF is called as a tetrahydrofuran, pyrrolidine. Examples: pyrrolidine, pyrrolidine. Then third may be as a tetrahydrothiophene, tetrahydrothiophene. And six membered ring, that is a polycyclic decahydroquinoline. Sorry, six membered ring, which is a piperidine. Here is a piperidine. That is example. And here decahydroquinoline, decahydroquinoline. And the example of decahydroquinoline you can draw here, which is a saturated ring. This is there, one of the hydrogen atom over here. Now THF, tetrahydrofuran, which is a saturated, I am showing over here THF. So this one, this is a structure of THF, tetrahydrofuran. This is known as a tetrahydrofuran. And now pyrrolidine, structure of pyrrolidine will be, I am showing over here, is a structure of pyrrolidine. Here this is a structure of pyrrolidine, structure of pyrrolidine. And structure of tetrahydrothiophene, which I am showing over here. See here is a structure of tetrahydrothiophene. 1, 2, 3, 4. There is a CH2 group, and there are 4, and therefore it is known as a tetrahydrothiophene. That is a structure of tetrahydrothiophene. Now six membered ring, the structure of piperidine. The structure of piperidine will be this one, N. Here hydrogen atom, there is a nitrogen atom, as we know that. So these are the how that classification of a heterocyclic compound can be carried out, can be done, that I have shown on the blackboards, so you can remember this. I think this is enough introduction regarding this heterocyclic compound. In our next lecture, we will learn the nomenclature of heterocycles. How do we name those heterocyclic compounds which we have seen just now? That we will see, we will learn in our upcoming lectures. Till then, have a nice day. Thank you.